Hello, what's up, everybody? How are you guys doing today? We started our series on indices, and I think we've completed that for now. So we're looking at logarithm in a couple of classes before we then move into something else. Now, logarithm is usually taught after indices because there's a relationship between indices and logarithm. Now, let me give you an instance here. So recall that if you recall this, that a raised power x, a was called the base and x was called the index, right? So the thing is that if you have a number like this, like 2 raised to power 3 is equal to 8, so 2 is the base, of course, 3 is the index, and 8 is the answer. So there is a relationship between this and logarithm in the sense that the logarithm of 8, so base 2, will give us 3, right? So remember that the base of 2 raised to power the index of 3 is going to give us 8. So I just do a logarithm, so logarithm of 8 then to base 2 is going to be equal to 3. So log, for example, there are a couple of rules that we need to learn. I think let's even go to those rules first. Laws of logarithm. So we have laws of logarithm. So remember that we also had laws of indices, right? We had about 5 or 6 of them. So laws of logarithm, they are not so much, at least for the scope of this particular lesson. So we're just going to look at 3 of them. So the first one says the logarithm, log of mn, like the logarithm of a multiplied figure, for example, so is equal to log of m plus log of n. So that's that. Now b, log m over n is equal to log of m minus log of n. So if you look at it for indices, then so what we for if you remember for indices we had if you have a times a, for example, then you add up the indices, right? And if you have let's say 5 raised to power 2 divided by 5 raised to power 1, so if you're having 5 then 2 minus 1 because of division sign, like. So the other way around is that for logarithm. So for logarithm, when there's a multiplication here, so you can expand it, but then you have to add the respective logarithms. And then the same for division, just that here you have to like subtract the respective logarithms. And then the third rule, if you have log m raised to power p, right? So when you don't have any base, so the assumed base is 10, right? So when you don't have any base in the question, the assumed base is 10. All right. So in this case, if you have log m, this is n, let's say log m b, and this is also to no, what am I writing? Log m raised to power b, and this is also so the base of m. So what this one becomes is there's going to the b, which is the index, comes to the back, and log m is m. This will give us 1. It's just like to the base of 10. So log 10 to the base of 10 will give us 1. Log 2 to the base of 2 will give us 1. So here we'll be left with b multiplied by 1, which is equal to b. And so these are like 3 nice things that we need to know about logarithm. And we are going to be applying them in our studies, like from a couple of examples. All right, so let's look at a few examples. For the first one, we have log 2 base 2 and 8. All right, so we can express 8 in terms of 2. This is going to give us log. So we are going to be having log 2 and 2 raised to power 3. So from this, we are going to be having 3 log 2 and 2. This cancels this, and then we have 3. So that's the answer to that. Now for the second one, you have log 381, for example. So this is still going to give us log 3, and express 81 in terms of 3. So from here, now we are going to be having 4 log 3 and 3 to cancel that, and then we have 4. Because log 3 to base 3 is going to give us 1, like I said earlier. So let me look at this other example here. Where you have log let's say we have log 525 raised to power minus 1. So how do you deal with this? This is going to give us log base 5. Now 25 on its own is 5 squared. 5 squared raised to power minus 1. Alright, so that's going to give us log 5. 5 raised to power 2 times minus 1 is minus 2. So we have minus 2 log 5, 5. Cancel out, and then our final answer is minus 2. So there's a fourth kind of example. Also still want us to talk about log 5 log base 5 0.04. All right. So for this, I think I remember then when we were talking about indices. If this is the base you have here, so just try to see if you convert your number here like in form of 5. So what do I mean? Let us express this here in standard form. So once you express it in standard form, 0.04 divided by 1. That's the same as what is here. And I shift this guy once, and it's has 0. I flip the guy once, and it's has 0. So at the end of the day, I'll be having 4 over 100. 4 here 1, 4 here 25, 1 over 25. That's 25 raised per minus 1. This guy becomes log 5. This guy is 5 raised per minus 1. So I continue, log 5. 25 on its 5 squared. Then raised per minus 1. So I guess I can erase this. I only just use this to get something. Alright, so when we proceed, we are going to be having log 5 raised per minus 2. So from here, I believe you know that the answer is going to be minus 2. So this the beginning of what we want to start talking about today, and I believe it is clear enough. So there's going to be an exercise on this for you to solve. It's just cool, right? It's not a problem. I want us to look into a different type of problem, and then we are going to combine your assignments, right? We are going to combine your assignments to what you've learned here and what you're going to learn there, and every other. All right, so we have this set of questions on the board. So how can we solve these kind of problems? So whenever you're given something like this, it is because you've not been given any. You're not supposed to use a four-figure table because you could also use four-figure tables to solve simultaneous equations. Just that the kind of thing I'm doing here this time around, we don't need four-figure tables. Like I said, the kind of mathematics that we are doing in economics is not to take us back to the whole of mathematics of high school. It's just to use these things as tools in other topics that we are really interested in. Alright, so if you look at this, you've been given log 2 at 0.3013, you've been given log 3 at 0.47712. So how can we then use this to get log 5 without using a calculator? Alright, so how do we go about that? So solution. Now if you remember that if you wanted to do for A, you wanted to do log 2, if you wanted to say log 6 equals log 2 times log 3, this is not correct. Right, so log 6, what I mean is, you wanted to say log 5. That's what I meant actually. The log 5, and log 5 should be equal to log 2 plus log 3 now, right? So if you remember that in what do you call it now, in logarithm, this log 2 and log 5, from that rule, one of the rules that we read, I think the first one, this simply means log into bracket 2 times 3, right, which is going to give us log 6. So if you wanted to solve for the second one, this is what we're going to do. But we cannot use it for log 5 because you cannot express log 5 in terms of, so log 5 is not equal to log 2 plus log 3. It is log 6 that is equal to log 2 plus log 3. Because 2 multiplied by 3. Then remember that rule where we said log mn equals log m plus log n. So that's the rule I'm talking about. So m times n is mn. So 2 times 3 will give us 6. So it's not 5. So how then do we go about solving the one for log 5? Alright, so what we are going to do is that we are now going to improvise. Log 5 is basically the same thing as log 10 over 2. Right? That's clear, right? So we can just go on and say, okay, let's do log 10 then minus log 2. So I've told you that if you're not giving what do you call it now, if there is no base, like if there is no base here, then that means your question is in base 10. So in that case, what that would mean is that this is going to be log 10 base 10. This is like log 2 base 10, which is the log 2 that you're giving your enemies. This one is also 2 base 10. So log 10 is going to give us 1 minus, then log 2 is going to give us 0.3010. So when we do the subtraction, we are going to get something like 0.6 thereabouts. Where is it? 0.69 0.69897 there also. So that's our final answer for that particular one. Um, and then I believe it is understood, right? So you are just like improvising. Okay, so we use the second rule here, to get our answer. That second rule that I wrote as log m over n. So we say log m over n equals log m minus log n. So that's what we just quickly improvised in this case. Alright, so for B, which was the first one that we wrote, to get our log 6. So log 6 is one that is basically equal to log 2 plus log 3. So what's log 2? 0.3010. Then we're given log 3 0.47712. And then that's going to give us where is it? 0.77815. 0.77815. And with that, you're done. Now the third one, which is like a little bit funny, you have log 0.9. So if you try to open this up, it's the same as log 9 divided by 10. Like, do you agree? Alright, good. And we can still open this up to give us a log. You have 3 times 3 divided by 10. So since we don't have like 9 in the equation, but we have log 3. So when we express the whole thing in full, we're having log 3, right? Plus log 3 plus this 3 times 3 is going to give us this 9 anyway. And the division sign here will mean minus log 10. And then you're fine. So log 3 plus log 3 is 2 log 3 though. Like log 3 in 2 places. So this is 2 log 3. You may decide not to do it this way. Like you may just log 3 and radius, right? 0.4771 there plus 0.47712 is okay. And of course, log 10 is going to give us 1. Okay, so 2 multiplied by log 3 as 0.477 whatever minus 1. So I'm going to have 2 into bracket 0.47712 and minus 1. So I didn't multiply this one out. So what I just have here is minus of course, because this is going to be lower, the answer that we're getting is going to be lower than 1. Right, so we have minus 0.0576. So something around this. But is it really supposed to be up to minus 0.04? Because I'm looking at this. Log 3, I'm thinking 2 times 0 points, this should be like 8. It should be 8. 7, so I'm not sure it should. Okay, 0.04. Okay, well, it's likely then that is the answer. So since we have 0.04, so like not 0.4. Okay, yeah, it's good. So with that, we've attempted a different kind of logarithm. We are not going to be using anything like four figure table like in this kind of lessons. Like I said earlier, it's not as if we are going over mathematics all over again. That's not what we're trying to do. So there are other exercises that we can also solve for you to continue to understand these things. So we have a third kind of logarithm questions on the screen. So after this particular one, we'll be looking at logarithm and exponential functions. That's going to be in a different lesson anyways. Alright, so how do we go on solving all of these questions? These are very easy questions. Like I said before, usually you are not expected to use a calculator, but then if you are to use a calculator, the question should like let you know. But here we just have to simplify the following as far as you can, as far as possible. So for the first one, which is A, log 8 plus log 5. So when we look at the first rule, this is going to become log 8 multiplied by 5, which is equal to log 40, and you're done. Like you're done, log 40, that's all. But except it's like an objective question, and you cannot find log 40 among the options. So you may decide to like just put log 40 on your calculator and you get your final answer out, that kind of a thing. Right, so the next one is 2 minus log 4. Now for us to do 2 minus log 4, this time alone you cannot subtract log 4. I remember I told you that whenever we don't have any base, so it means that our questions are in base 10, right? So what we just have to do here is this is actually going to be equal to 2 log 10 minus log 4. So I want to believe that this is clear. This is clear. Alright, so when we continue with this, we'll be having log 10 squared. Remember that rule, right? Whenever you have log a raised per n, that becomes n log a. Okay, so we also introduce ourselves to it. We've used this before now, so we can use it the other way around as well. So remember log 10 is 1, so we can just do our manipulations and get this 10 minus log 4. So log 10 squared is basically log 100 minus log 4. So how do we continue with this? Then apply a different rule. That rule that says something like this becomes log 100 into bracket divided by 4. So our final answer here becomes log 25. And yeah, that's all. Okay, we've simplified it like the lowest rule. Except again, your question wants you to include the final answer at the end of the day. Now for C is log 9 divided by log 3. So here it's looking like, oh wow, it's like unique, different from everything I've been doing before now. So what you do the division like straight up. So this is going to be log 9 divided by log 3. Alright, but then the thing is that we can also express log 9 in form of log 3. So this is like log 3 squared, right, divided by log 3. And we know that whenever we have this like that, we just have 2 log 3 divided by log 3. So this will cancel out and then we have 2 the final answer. So it's not that difficult. Now D looks difficult, but like it is really simple. 2 over 5 log 32. So what we have to do is we have to do two things. First, we have to bring the power of 2 over 5 up to this side. So we have log. But then we can also express 32 in the form of something similar. 2 raised to 5, for example, is same as 32. Then we bring the power. Okay, let me do it this way so I don't confuse you. So 2 over this is equal to 2 over 5. Log 2 raised to 5, right? So from there we are going to have log 2 raised to 5, right? Then all of this raised to 2 over 5. I want to believe I'm not confusing anybody here. 2 over 5 is still 32. We just kind of express 32 in a way that can help us like deal with the formula, deal with the other index in an easier way. So 5 will cancel this 5 here. So we'll be left with log 2 raised by 2, and this gives us log 4. And yeah, so that's it. Log 4. So we are done. Alright, so that's all about this set of questions. So if you have any question, you can leave them in the comment section. What you're going to get now is an assignment for you to just play and practice with. So here are your assignments. They are a handful, right? Covering everything that we've done today. So they are not actually difficult. So section A, evaluate the following: log base 24, log 7 1 over 7, log base 16 0.25, then number 4, log base 1.2 1.728. So when you're done with all of those, then you move to giving log 2 equals 0.3010, log 3 as whatever, then calculate all of this: log 7, log 14. No, you'll be given log 7, so find log 14, log 42. Therefore, C, evaluate the following: log 81 minus log 3, 3 over 4 log 16, 2 minus 2 log 5, 3 log 2, whatever, and log 0.2 divided by 0.5. So these are 5 questions, these are 2 questions making 7. And then we have 4 questions there. Maybe I could just take this off. Maybe I should just take one off. So I'm just going to have 10 questions. Okay, let me just take this guy off. Because it's pretty simple anyways. So this is number 1, number 2, number 3. Alright, so all in all, we are going to be having 10 questions, 10 straightforward questions. Thank you. See you in the next lesson. We'll be talking about logarithm and exponential functions. Bye bye and take care of yourselves.